kung where nga gin-raise ang inyong reactant concentration. So to define, if the reactant concentration is in a zero order reaction, so it means that the rate is independent of the concentration of the reactant. So regardless if we change the concentration of the reactant, so it will have no effect on the rate of reaction because the rate is independent of the concentration of the reactants. Next, for first order reaction, it's a reaction whose rate depends on the reactant concentration raised to the first power. So for a first order reaction, doubling the concentration of the reactant also doubles the rate. Okay, so how will you know if that is a first order reaction? So if the exponent of the reactant concentration is 1. All right. Next, for second order reaction, the rate depends on the concentration of one reactant raised to the second power or on the concentrations of two different reactants, each raised to the first power. So if may makita ka mo nga reactant concentration nga na-raise siya sa second power, or if may duha ka reactants, each raised to the first power. So that is a second order reaction. Okay? So for the third order reaction, actually this is not really talked about because this is a very rare situation. Okay, so it's experimentally determined. But if you come across this type of reaction order, so balaan mo na third order siya if a single reactant is raised to the third power, or if we have three reactants, each raised to the first power, or if we have two reactants, the other reactant is raised to 2 and the other is raised to 1. Okay, next. So here we have an example. So the rate equals to K times rate times concentration of your hydrogen and hydroxide ion. So each of the reactants here are in the first order reaction. But overall reaction order is second order. So for the overall reaction order, all you have to do is add the exponents of the reactants. All right. Next, another example here is of the third order. So one reactant is raised to 2, another reactant is raised to 1, so 2 plus 1 is 3. So this is then a third order reaction. Okay, next. Let us proceed. So I believe are we done discussing this, guys? Writing rate laws from reaction orders. Wala ako na ma-keep track kay nagdugang ako sa number of slides. So hindi. So wala na nag-coincide ang ginhambal ko nga slide number. Okay, so I think tapos na kita din. Ano na gali kita? Collision theory. Okay, sige. So what is collision theory? So we should not be surprised that atoms, molecules, or ions must collide before they can react with each other. Excuse me.
Okay. So atoms must be close together to form chemical bonds. This simple premise is the basis for a very powerful theory that explains many observations regarding chemical kinetics, including factors affecting reaction rates. Collision theory is a theory that assumes that for reaction to occur, reactants must collide with an energy greater than some minimum value and with the proper orientation. So shown on the slides are two collisions that might take place between carbon monoxide and oxygen molecules. So if you notice here in the first example, so with carbon on the left side of your oxygen molecule here plus the oxygen molecules, so it will have no reaction because sala ang iya nga orientation. So if we were to form or produce carbon dioxide, so dapat carbon is in between the two oxygen molecules. Because in determining the proper orientation of the reacting molecules, we need to take into consideration how they bond with other atoms. All right. So the orientation of the colliding molecules partially determines whether a reaction between the two molecules will occur. Collision theory explains why most reaction rates increase as concentrations increase. With an increase in the concentration of any reacting substance, the chances for collisions between molecules are increased because there are more molecules per unit of volume. So more collisions mean a faster reaction rate, assuming the energy of the collisions is adequate. Okay. So again, take note, in order for reaction to occur, two criterias must be met. So the first, there must be adequate energy. Dapat ma-reach niya ang minimum energy or greater than the minimum energy. And the second is proper or correct orientation of the reacting molecules. So that minimum energy is what we call activation energy. So represented by this abbreviation. Small letter big letter E, subscript A. So this is a minimum energy of collision required for two molecules to react. Okay? Next. So once this activation energy is reached, an activated complex or a transition state is formed. So this is a temporary species formed by the reactant molecules as a result of the collision before they form the product. So here we have a GIF showing us how reactants, when they reach activation energy where their particles collide, will then form the activated complex here and then will proceed in forming the products. Next, the collision theory is based on the following postulates. First, the rate of a reaction is proportional to the rate of reactant collision. So, dapat may collision skid kita. Okay? Second, so the reacting species must collide in an orientation that allows contact between the atoms that will become bonded together in the product. And third, the collision must occur with adequate energy to permit mutual penetration of the reacting species' valence shells so that the electrons can rearrange and form new bonds and new chemical species. All right. Next, a balanced chemical equation is a description of the overall result of a chemical reaction. However, what actually happens at the molecular level may be more involved than is represented by a single equation. The reaction may take place in several steps. So, these steps is what we call the reaction mechanism or reaction pathway. So this is a process or pathway by which a reaction occurs. So a chemical reaction usually occurs in steps, although it may not be always be obvious to an observer. So aware kita, 'di ba, if there is a reaction, it's a step-by-step process, no? But usually what is shown to us is just the overall reaction. So just like at our example here, the decomposition of ozone. Yun. So amula ni siya ang ginapakita sa aton. But at the molecular level, before ozone here decomposes to your oxygen molecule, it follows two steps. It involves two steps here. But if you look at the overall reaction here, hindi mo makita ang ining duha ka steps ngani. Okay? So we call each step in a reaction mechanism an elementary reaction. Elementary reactions occur exactly as they are written and cannot be broken down into simpler steps. Notice that the oxygen atom produced in the first step of the mechanism is consumed in the second step and therefore does not appear as a product in the overall reaction. So ano ang ginamin ng oxygen atom? So you look at the steps here. So the one above is the first step. So notice that your ozone decomposes to an oxygen molecule and an oxygen atom. This oxygen atom is then consumed in the second step here. All right? So species like your oxygen atom is what we call intermediates or reaction intermediates. So it is produced in one step and is consumed in a subsequent step. So while the overall reaction equation for the decomposition of ozone indicates that two molecules of ozone react to give three molecules of oxygen, the mechanism of the reaction does not involve the collision and reaction of two ozone molecules. Rather, it involves a molecule of ozone decomposing to an oxygen molecule and an intermediate oxygen atom. After which, the oxygen atom here then reacts with a second ozone molecule to give two oxygen molecules. So these two elementary reactions occur exactly as they are shown in the reaction mechanism. So in reality, guys, ang ginapakita sa inyo is just the overall reaction na. No, wala na ni ginapakita ang inyo nga elementary reaction or elementary steps. Let's have another example para magets nyo pagid. Okay? So let us consider the reaction between nitric oxide and oxygen. So we know that the products are not formed directly from the collision of two nitric oxide molecules with an oxygen molecule. Because dinitrogen dioxide N2O2 is detected during the course of the reaction. So in the first elementary step, two nitric oxide molecules collide to form dinitrogen dioxide. This event is followed by the reaction between N2O2 and an oxygen molecule to give two molecules of nitrogen dioxide. The net chemical equation or the overall reaction here, which represents the overall change, is given by the sum of the elementary steps. Okay. So from the overall reaction here, as you can see, your N2O2, yes, it's included here, but it's canceled out because your N2O2 is an intermediate. Therefore, it does not appear in the overall balanced equation. However, it does appear in the elementary steps here, but it should not be included in the overall balanced equation. All right. So guys, don't worry. Katie, I will not require you to write this. Okay? Ginapakita ko lang sa inyo nga before this overall reaction happens, may gakatabo nga elementary reaction. So, kumbaga, kung sa sine, kung sa movie, your elementary reactions are the behind the scenes. All right? Next. Elementary reactions are classified according to their molecularity. To define molecularity is the number of molecules on the reactant side of an elementary reaction. So we have three classifications depending on the number of reactants. So for unimolecular, so of course it involves one reactant. Bimolecular, two reactant molecules, and this is the most common. And for thermolecular, so this usually occurs in gas phase reactions and it involves three reactant molecules. All right. Next, let's proceed. Chemical equilibrium. By the way, tapuson ta lang ang muni nga discussion ha, and then we will continue next meeting. By the way, for next meeting, ang discuss naton is acid-base equilibrium. Okay, so that you can do your advanced research and study. Okay, so what is chemical equilibrium? Few chemical reactions proceed in only one direction. Most are reversible, at least to some extent. At the start of a reversible process, the reaction proceeds toward the formation of products. As soon as some product molecules are formed, the reverse process begins to take place, and reactant molecules are formed from the product molecules. Chemical equilibrium is achieved when the rates of the forward and reverse reactions are equal and the concentrations of the reactants and products remain constant. Chemical equilibrium is a dynamic process. This dynamic equilibrium consists of a forward reaction in which substances react to give products, and a reverse reaction in which products react to give the original reactants. So both forward and reverse reactions occur at the same rate. So how will you know if it's in the forward or in the reverse process? So let's take for example the equation shown on the slide. No? So we have dinitrogen tetroxide. So if it proceeds in the forward direction, it will produce 2 moles of nitrogen dioxide. And take note, we have a reverse arrow here, which means that the two molecules or the 2 moles of nitrogen dioxide here can be converted back to dinitrogen tetroxide. So the formation of NO2 from N2O4 is what we call a reversible reaction. So how will we know? So this is identified by the equilibrium arrow or the reversible arrow here, no? So the forward direction and the reverse direction. From reactants to products and products to reactants. That is why a system at equilibrium has an equal rate of decomposition of the reactants and equal rate of the formation of the products and vice versa. All right? So all reactions are reversible, but many reactions for all practical purposes proceed in only one direction. So such reactions are depicted with a one-way arrow from reactants to products only, no? So amo ni siya ang mga examples naton earlier. So it only proceeds in the forward direction. But in cases wherein we have reversible reactions, so pwede kita ka-convert reactants to products and products to reactants. All right, let's proceed. So now that we have a symbol to designate reversible reactions, we will need a way to express mathematically how the amounts of reactants and products affect the equilibrium of the system. A general equation for a reversible reaction may be written as shown on the slide. So here we have a balanced chemical equation, no? So A and B, reactants, C and D are the products, M and N, X and Y are the coefficients of the reactant and products respectively. We can write the reaction quotient represented by letter Q for this equation. So take note, when reaction quotient is evaluated using concentrations, it is called QC. So C is for concentration. That is why present diri ang inyong nga brackets. Okay, I hope gets nyo ko nga may brackets dira, no? Based from our previous discussions, 'di ba? Brackets here indicate molar concentrations. Okay? So as you can see, the products is in the numerator and the reactants are in the denominator. And take note, their coefficients become their exponents here. Okay? So please take note of this expression because this is going to be used in solving problems involving your QC. So which means that the reaction quotient here, QC, is equal to the molar concentrations of the products of the chemical equation multiplied together over the reactants also multiplied together with each concentration raised to the power of the coefficient of that substance in the balanced chemical equation. So basically, guys, this QC expression is derived from this balanced chemical equation here. So if sala ang pagbalance mo, so matik, sala man na di ang imo nga mabutang sa QC expression. So dapat, sa balancing pa lang, tsakto na, kabalo na kamo mag-balance. Kay if sala ang pag-balance, automatic, sala man na di ang masulat ninyo sa QC expression. Sala man ang magamit ninyo nga exponents for solving for the reaction quotient. Alright? So, where are you going to start first? Balancing chemical equation. So, dira pa lang, dapat kabalo na kamo. Let's have an example here. The reaction quotient for the reversible reaction. 2 moles of NO2 to form your N2O4 and vice versa. So this is the balanced chemical equation for this reaction. So if we were to express this using QC, so this will be the QC expression. So the product N2O4 is in the numerator and the reactant is in the denominator here. Take note, the coefficient now becomes its exponent. Take note, the reactant and the products are enclosed in brackets because it indicates molar concentration of the reactant and product. Okay, so base magsala ka mo ha, base reactant reactant ang mabutang nyo sa babaw kag product ang sa dalom, no? So subong pa lang, take into heart nyo na the product is in the numerator and the reactant is in the denominator. All right. Let's have an example. So practice example ha. Okay? So may kodigo kita diri. Okay? Para hindi ka mo ma lost or ma-confuse kasi it's your first time encountering this. So we have three reactions here. So these are already balanced chemical equations here. So all you have to do is write the QC expressions for these chemical equations. Okay? So since first time, lantawon ta ang solution. So ano ka mo anay ah? Observe anay and familiarize anay ah. Okay? So for letter A, of course, QC equals the molar concentrations ng ozone natin raised to 2 over molar concentration of O2 raised to 3. Oh, amo lang man na. Hapos lang, 'di ba? Letter B, amo man gihapon. Product in the numerator, reactant in the denominator, and the coefficients become the exponents. Same is true with your letter C. No? NO2 and H2O, the products in the numerator, plus their coefficients that are now their exponents. And in the denominator, we have your ammonia and oxygen here with their respective exponents. Alright? So, amo lang man na siya, no? So, very helpful good ini siya if we solve for QC later on. Okay? So, when a mixture of reactants and products of a reaction reaches equilibrium at a given temperature, its reaction quotient always has the same value. This value is called the equilibrium constant or K of the reaction at that temperature. As for the reaction quotient when evaluated in terms of concentrations, it is noted as Kc. So C for concentration. So as seen here, Qc at equilibrium equals to Kc. Hence, they have the same expression. All right. So the equation is a mathematical statement of the law of mass action, defined as when a reaction has attained equilibrium at a given temperature, the reaction quotient for the reaction always has the same value. All right, that is why QC at equilibrium equals to Kc. Okay, next. Let's try to solve.
Okay. So, ginkuha ko lang ako nga headphones ha. So, the problem reads, when 0.10 moles of nitrogen dioxide is added to a 1 liter flask at 25 degrees Celsius, the concentration changes so that at equilibrium, concentration of NO2 is 0.016 molar and concentration of N2O4 is 0.042 molar. What is the value of the reaction quotient before any reaction occurs? And what is the value of the equilibrium constant for the reaction? Okay? So given is the balanced chemical equation, the composition of NO2 to N2O4 and vice versa. Okay, let's start first with letter A. What is the value of the reaction quotient before any reaction occurs? So it may not be obvious to you, but the given is already in the problem. Okay, so take note, before any reaction occurs, so wala pa nag-start ang reaction. So therefore, wala pa kita sang product concentration. So all we have is just the reactants, which is your NO2. So before any reaction occurs, we need to know the molarity, molar concentration of the reactant, and of course, your N2O4. So for letter A, ang inyo diri nga hint is before any reaction occurs. Alright? So given in the problem, we have number of moles of NO2 and the desired volume, which is 1 liter. So this will give us the molarity sang aton nga NO2. Okay? So in solving for molarity, so 0.10 moles divided by 1 liter. So molarity for NO2 is 0.10 molar. Next, N2O4. Why is it that 0 ang iyang concentration? Oo nga, 0 ang concentration. Sang inyong nga N2O4 dira. Oh, ang hint ninyo letter A. Before any reaction occurs. So meaning, wala pa kita sang product formation. Therefore, 0 ang concentration ng aton na N2O4. Okay? So after that, you need to write the QC expression. O, para klaro sa inyo ang inyong working formula. Okay? So the product is in the the product is in the numerator and the reactant is in the denominator. So concentration for N2O4 is 0 and concentration for NO2 is 0.10 raised to 2. But anyway, the answer is still 0. So the QC is 0. Take note, wala na siya unit. Next, letter B. What is the value of the equilibrium constant for the reaction? Oh, so meaning, may anak na kita sang equilibrium concentration. Di ba la? So that is also given in the problem there. So at equilibrium, NO2 is 0.016 and N2O4 is 0.042. So again, don't forget to write the Kc expression, di ba? QC at equilibrium is equal to Kc. Alright? So 0.042 divided by 0.016 raised to 2, and this will give us a QC of 1.6 1.6 times 10 raised to 2. So this is the QC at equilibrium, no, for the reaction of NO2 to give N2O4. Take note, wala unit. That's it. That's how simple it is to solve for QC and KC. So make sure dapat balance ang chemical equation first. After which, of course, you need to write the QC or KC expression. And then, substitute the values given in the problem. Next, Homogeneous equilibria applies to reactions in which all reacting species are in the same phase. All right? So, as seen on the slide, you have there reactant and the products are all in the same phase. No, they are in the aqueous phase. Okay, next. So, in writing equilibrium constant expression for homogeneous equilibria, so same lang man siya with how we did it in the previous slides, no? So there is no problem with this. Next, what about for gaseous reactions? So for gases, we use partial pressures. So this is your Kp. So P stands for pressure. So as you can see, lain man ang way in writing Kp expressions. No? So as you can see, the reactants and products are not enclosed in a parenthesis. It's because your Kc is not equal to Kp because the partial pressures of reactants and products are not equal to their molar concentrations. That is why wala naka-enclose sa brackets here. And take note for KP expressions, may nakabutang nga letter P before the name of the reactant and the product and dira man ginabutang ang exponent. Alright? Next, let's try to solve. The following equilibrium process has been studied at 230 degrees Celsius. So reaction of 2 moles of nitric oxide with oxygen molecule to give us 2 moles of nitrogen dioxide. So in one experiment, the concentrations of the reacting species at equilibrium are found to be 0.0542 molar for nitric oxide, 0.127 molar for oxygen, and 15.5 molar for nitrogen dioxide. Calculate the equilibrium constant of the reaction at this temperature. Okay, so step-by-step process. Check first if your equation is balanced. If it's balanced, then you can write the Kc expression. Kc expression is derived from the balanced chemical equation. And after that, substitute the given values in the problem. Sige be, kamubi try, and then we will check afterwards. Okay, ate ano inyo nga sabat? Sorry na naog ko guys, nagtimpla ko kape. Grabe, gid kuya katuyo, ya as in wakal ako, nagapiyong akong mata sa inyo. Ay, ate ano inyo sabat? Nag-try ka mo sabat? O sa mga nakasabat, ano inyo sabat? What is your answer? O sige, Miss Baladhay, o.
1.8 times 10 raised to 3, ma'am.
Abe, natawon ta ha. We will proceed to the solution. Ay, sorry. Oy! Ay, ang amo kay mani. Yes, oh. Oo nga, anak 1.8 ikaw. Kasi nalipat ikaw sang ano? Sang ilang exponents. Oh, yes.
Ma'am, ask lang po ma'am if dapat scientific notation gid ang answer.
Kung amo man ako ginapanumdum, kung dapat kadamos ang zeros, pwede gyud siya nga scientific notation. Para kay mas malipot if naka scientific notation eh. Diba? So, did you get the correct answer bisan hindi siya naka scientific notation?
Yes, ma'am. 6
Okay.
642.
Yes? Miss
Ma'am,
Nami?
ma-follow ma'am, sig figs ma'am. Akong
Ang kung mag-test kita,
Yeah.
ako na ma-decide,
Pero
ako na
okay gid
mahambal
man
sa
siya
inyo.
mga scientific notation gid siya no kay conduct.
Yeah, oo. Mm-mm. Scientific notation, mas nami tulukon na naka-scientific notation. Okay? So anyway, if amo lang man na siya ang problem nga ma-encounter ninyo, hapos naman lang siya, no? Kaya all you have to do is balance the equation and then you write the QC expression here and then you substitute the values. So, hindi pagkalimtan ang mga exponents gani. So, it's part of the computation here. Okay? So, the answer is 6.44 times 10 raised to 5. Take note ha, wala ni siya unit. Alright? O, sa mga salaang sabat, ang i-identify nyo da kung diin ka mo nagsala para sa next time nga mag-compute ka mo, you will learn from that mistake kag mag-insyakto na ang inyo nga sabat. Alright? Next. Another solving. Sige. So this time, this involves partial pressure naman. Okay? The equilibrium constant Kp for the decomposition of phosphorus pentachloride to phosphorus trichloride and molecular chlorine is found to be 1.05 at 250 degrees Celsius. If the equilibrium partial pressures of PCl5 and PCl3 are 0.875 atmosphere and 0.463 atmosphere respectively, what is the equilibrium partial pressure of chlorine at 250 degrees Celsius? So take note, concentrations of the reacting gases are given in ATM, no, or atmosphere. So from the known Kp value and the equilibrium pressures of PCl3 and PCl5, we can solve for the partial pressures ng aton nga chlorine. O sige. So the first thing that you're going to do is write the KP expression. So after writing the KP expression, then substitute the value. So this time, guys, given niya ang KP. No? Hapos tani if ang KP ang inyo nga isolve. But no. So given ang KP, which is 1.05, given man ang pressure sa PCl5 and PCl3. So ang pangitao ninyo is the pressure for chlorine. So ano ayhan ang sabat?
1.98.
Okay. Yon. Sige, very good. So here is the KP expression. So note nga may mga P before the names of the reacting species, no? And of course, the products. All right. And after which, we substitute the value. So Kp is 1.05. We have here the pressure for PCl3 and the pressure for your PCl5. So transpose na naman ni ang matabo. Di ba la? Kaya X ang inyo nga pressure for your chlorine. So to find out the partial pressure for chlorine, we multiply the Kp with the with the partial pressure of PCl5 divided by partial pressure of PCl3. And this will give us 1.98 atm. So this is the partial pressure for molecular chlorine. Okay? Sige, So, amoy niya ang ginhatag ko para at least aware ka mo nga may amuni nga form sa problem solving. Kaya di kung pangitaon nyo ang KP, hapos lang man na iya, di bala? Times nyo man lang na di ang value sa babaw, kung i-divide nyo man lang sa value sa dalom, ara na ang KP. Hapos lang man niya ang KP. Okay. Next. Heterogeneous equilibria. So kung ang homogeneous, same phase ang reactant and product, ang sa heterogeneous naman niya, the reactants and products are found in two or more phases. So the phases may be any combination of solid, liquid, or gas phases and solutions. So take note, when dealing with heterogeneous equilibria, solids and pure liquids do not appear in the equilibrium constant expressions as shown here on the slide. No? So here we have the chemical equation, opposite it, the Kc expression for the reaction. So as you can see, wala na ginadala ang inyong solid substances. Alright? Next, for gases naman ya, so we still use partial pressures man gihapon. Alright? So, always remember, basta heterogeneous, wala ginadala ang solid and pure liquid sa equilibrium constant expression. So, let's have an example. So, here we have a reaction, calcium carbonate to yield calcium oxide and carbon dioxide. Oh, ano matabo? Kay ti duha ka solids ang ari sa equation. What will the Kc expression look like? Oh, so ang i lantawon lang naton is the carbon dioxide here. Diba la? So, walay na ni si calcium carbonate kag si calcium oxide. So, Kc expression will look like this. Yun. Mulang na siya. Just the concentration of carbon dioxide. Alright? So, please guys, ang ining mga writing Kc expressions, i-take into heart yun ni ha. Kasi, kumbaga, para makabawi-bawi man kamo or at least makapuntos man kamo sa quiz or sa exam. Okay? Ang exam ta nga daan, ano na? Ano gani? Face to face na. So, pwede gid kamuya kasulat. No? So, budlay lang niya kung sa canvas, kati ma-type ka pa. At least kung ara, sulat, o diretsyo. Okay, sige. Next. Predicting the direction of a reaction. Sige. So, maamat-amat challenging ang aton nga obrahon. To determine the direction in which the net reaction will proceed to achieve equilibrium, we compare the values of QC and KC. So we have three statements below. So I also want you to learn this. No, hindi lang nga familiarize. Yeah, memorize so nyo gidya kag inshindihon gidya i-analyze gidya para mag-gets nyo dayon ang concept. Okay. So if the QC value is less than KC, what does this tell us? So this tells us that the ratio of the concentration of the product to the reactant is small. Ti ano dayon kung small, ma'am? Take note ha, gamay ang concentration sa product compared sa reactants. So if you ask yourself, so is the system or is the mixture at equilibrium if amo sina? Hindi, di ba la? Kaya ti ano kung makahambak ang equilibrium, how? Di ba, kumbaga equal, balanse, equal, balance ang rate of consumption ng reactants sa rate of formation ng products and vice versa. Pero kung amo ni siya nga nubo or gamay ang concentration sa products compared sa reactants, then the system is not at equilibrium. Uti, kung hindi siya at equilibrium, pabayaan ta lang siya. Nami matani, kung pabayaan na lang, no, kaya ti, kebs kumaniya. Ahay. Hindi. we need to reach equilibrium. Okay? So, paano ma-reach ang equilibrium nga na if nubo ang concentration ng product compared sa reactants? So, kung nubo ang product concentration, buot silingon, dapat taaso naton ang product concentration, di ba la? Di ba la, guys? So, ano ayhan ang direction sang reaction if taaso naton ang concentration sang product para ma-reach naton ang equilibrium? O, ang sabat actually ara na da sa slide, no? Pero gina gina bato-bato ko para maintindihan ninyo. O balikan ninyo ang inyong chemical equation. Diba sa hindi nyo maintindihan nga left to right ang nakabutang dira sa statement. O balikan ninyo ang chemical equation ninyo. Ano gani ang hambal naton sang prelim? Diin nga side ang reactants, diin nga side ang products. Kay man, di ba sa long quiz, damo nagsala, dira mo. Hindi sila kabalo kung diin ang products, diin ang reactants nga side sang equation. So, ang reactants naton are always in the left side and the products are in the right side. Di ba la? So, if nubo ang concentration sang products, kagusto ta siya taason. So, dapat ang mga reactants naton i-convert naton to products, di ba la? So the reactants need to be consumed to form the products. Therefore, the direction of the reaction must proceed from left to right. Consuming the reactants to form the products. That is why left to right siya. That is kung nubo ang concentration ng products as compared to the reactants. That describes QC is less than the value of the KC. Next, wala kita problema sa QC equals KC because it tells us that the system is at equilibrium. Wala problema. Next, i-deal naman natin ang opposite sa QC less than KC. So, QC greater than KC, which means to say, ang concentration sa inyong product, dako na naman siya compared to the reactant. Hindi na ka mo manumdum. Opposite lang na siya sa inyong QC less than KC. So if dako ang concentration ni products compared sa reactants, so kinahanglan naton i-convert na naman ang products naton to the reactants. Okay, kumbaga guys, it tells us nga if taas ang concentration ni product, meaning sila nubo ang concentration sa reactants naton, di ba la? Excuse me. Oh, pasensya gid ha. Oh, sige. So kung mas dako ang product na concentration, buo silingon gamay ang concentration sa aton nga reactants. So that is why we need to convert some of the products to reactants para magtaas-taas man ang concentration ng atong nga reactant. That is why in a system wherein QC is greater than your KC, the direction of the reaction will proceed from right to left. So consuming the products to form the reactants to reach equilibrium. Dumdumon nyo ha, a system at equilibrium has an equal rate of formation, equal rate of consumption of the reactants and equal rate of formation of the products and vice versa. Reactants to products, products to reactants. All right. Let's have a problem solving in relation to this. At the start of a reaction, there are 0.249 moles of nitrogen, 3.21 times 10 raised to negative 2 moles of hydrogen, and 6.42 times 10 raised to negative 4 moles of ammonia in a 3.50 liters reaction vessel at 375 degrees Celsius. If the equilibrium constant for the reaction is 1.2 at this temperature, decide whether the system is at equilibrium. If it's not, predict which way the net reaction will proceed. So given, of course, the chemical equation here, given man ang number of moles and ang volume, which explains, which tells us that we need to solve for molarity. Di ba? Molar concentration gani ang atong gina-consider. Alright, sige. Go on. So we need to solve first for molarity. So given naman sa problem, no? Number of moles ang atong nitrogen, hydrogen, and ammonia, and also the desired volume, which is 3.50 liters. Okay? So if you come across a problem na ml ang given, ano kinahanglan ninyo obrahon? Very good. You convert ml to liters. Kaya ang molarity naton is moles per liter. Okay? Kung may kung ml or milliliters ang given, you need to convert milliliters to liters. So anyway, no problem man sa among nga problem naton kay the volume is already in liters. So diretso na kita sa pag-solve sang aton nga molarity. So molarity for N2 is 0.0711, for H2 is 9.17 times 10 raised to negative 3, and for ammonia is 1.83 times 10 raised to negative 4. Okay? After that, we write the QC expression so that we can have a picture of our working formula, after which you substitute the values. All right? And this will give us a QC of 0.611. Oh, balikan ta ang question. Decide whether the system is at equilibrium. If it is not, predict which way the net reaction will proceed. Oh, QC is 0.611. Kc is 1.2. It's already given in the problem. Oh. So let me ask you, is the system at equilibrium? Okay, very good. Lagi sa may nagasabat. The system is not at equilibrium. Kaya your Kc is 1.2, your Qc is 0.611. Di ba la? So what does that tell us? So if the system is not at equilibrium, then which way the net reaction will proceed? O i-compare ninyo ang Kc ninyo and ang Qc ninyo. Kc is 1.2, Qc is 0.611. O tian nyo na siya, greater than or less than?
Less than, ma'am.
O ano ang less
So,
than?
left to right siya, ma'am. Proceed siya left to right.
Okay. So QC value is 0.611. KC is 1.2. So QC is less than KC. So this tells us that the reaction will proceed from left to right. Kaiman, the concentration of the product is less compared to the concentration of the reactant. So we need to consume the reactants to produce more of the products. Yun. Okay, so damo lang kamo ipang consider if you will solve for this, no? So kinahanglan nyo pa-memorize ang ining statements kani. Kinahanglan nyo pa mag-balance ng chemical equation. Kinahanglan nyo pa mag-write ng QC expression. Kinahanglan nyo pa mag-solve. Sige. Let's proceed. Okay, factors affecting chemical equilibrium. Chemical equilibrium represents a balance between forward and reverse reactions. In most cases, this balance is quite delicate. Changes in experimental conditions may disturb the balance and shift the equilibrium position so that more or less of the desired product is formed. There is a general rule that helps us to predict the direction in which an equilibrium reaction will move when a change in concentration, pressure, volume, or temperature occurs. The rule, known as Le Chatelier's principle states that if an external stress is applied to a system at equilibrium, the system adjusts in such a way that the stress is partially offset as the system reaches a new equilibrium position. The word stress here means a change in concentration, pressure, volume, or temperature that removes the system from the equilibrium state. Simply speaking, when a chemical system at equilibrium is disturbed, it returns to equilibrium by counteracting the disturbance. So, kumbaga, kung i-relate siya sa pang-adlaw-adlaw nato nga ginaubra, no, ang stress hindi gid maiwasan. Di ba la? So ano aton ubrahon? Di ba we need to remove that stress in our life para maging okay na naman kita. Di ba la? So amo man ni siya sa mga equilibrium systems naton. So if gubuon mo, i-disturb mo, tagaan mo stress, ang system at equilibrium. So ano ina siya, maguba ina ang iya nga balance. So the system will need to remove that stress or counteract that stress in order for it to reach equilibrium again. Okay? So your Le Chatelier's principle is very helpful in what do you call this? In telling us which way, which direction will the system shift in order to counteract the stress. So we will use your Le Chatelier's principle in all the factors that we will be discussing. So the first factor is changes in concentration. A chemical system at equilibrium can be temporarily shifted out of equilibrium by adding or removing one or more of the reactants or products. The concentration of both reactant and product then undergo additional changes to return the system to equilibrium. Okay, so for changes in concentration, I want you to remember these two statements here. So we are given two scenarios here. What if you added the concentration of the reactant or if you remove a product? Oh, analyze nyo ha. Madugang ka sang reactant or nag-remove ka sang product. Diin ayhan nga direction ma-shift ang system para ma-counteract ka ina ang additional of the reactant and removal of the product. O, actually, na-mention to na ni Kagina sa QC is less than KC, di ba la? Siyempre, kung nag-remove ka sa product, gamay ang concentration sa product ninyo as compared to your reactants. Di ba la? Buot silingon, mas taas ang concentration sa reactants naton. Di ba la? So to reach equilibrium, the system will shift from left to write. Consuming the reactants in the left side to produce or to form products in the right side. Diba la? So, ang muna din nakabutang, no? When more reactant is added or some of the product is removed from an equilibrium mixture, thereby changing the concentration of the reactant or product, net reaction occurs left to right. So that is in the forward direction. To give a new equilibrium and more products are produced. Diba la? So nagdugang kasang concentration ng imo nga reactant. So ang dugang sina sa concentration si kinahanglan mo na i-convert to products. Same is true if kung nag-remove ka sang product. Di ba la? So, you need to convert your reactants to products. Okay, next. Oh, we will deal with the opposite. So, if product is added or reactant is removed, so baliskad. The reaction will proceed from right to left. So, it's in the reverse direction. No? So, we need to convert the products into reactants to counteract the removal of the reactant or the addition of a product. Alright? Wala kita problema. Diri ha kay same concept is involved sa aton nga gin-discuss earlier. Sa QC less than KC, QC greater than KC. Diba? Next. Applying Le Chatelier's principle when a concentration is altered. O sige B, predict the direction of reaction when hydrogen is removed from a mixture in which the following equilibrium has been established. O, para mas maintindihan, ara dira ang chemical equation. So from the chemical equation, we see that hydrogen is the reactant. Ano ang hambal? Hydrogen is removed. So, sa mapamatyagan nyo, since gin-remove ang hydrogen, sa ano ayhan nga direction ma-shift ang equilibrium to counteract this removal of hydrogen.
Right to left, ma'am.
Okay, very good. O, di ba? Siyempre, ginbuhinan mo ang hydrogen diri. So, you need to convert the products to reactants para ma-counteract ang pag-remove sa inyo nga hydrogen. Kumbaga guys, isipon nyo lang nga daw sa siso lang na bala, di bala? Kung kulang diri sa pihak, dapat i-compensate sa pihak na side para mag-balance ang siso. Diba? Okay. Yun. So, very good. So, from right to left. So, it's in the reverse direction. So, your hydrogen iodide here needs to dissociate back to hydrogen and iodine. So, amo man gihapon ang concept, let's say, if you remove iodine, amo man gihapon. Right to left man gihapon. So, your products need to be converted to the reactant to compensate for the removal of your iodine here. O, di ba la? Another scenario, ma'am, what if nag-remove ka sang product? O, gin-remove mo some of the HI here. So, of course, ang inyong nga reactants need to be converted to your products here to compensate for the removal of the product. Di ba na? I hope na intindihan ha. Hapos lang iniya ang changes in concentration. Okay? Next. What about pressure change? So in pressure change, guys, ang gina-consider diri naton are the gases. Okay? So we can change the position of equilibrium by changing the pressure of a system. So changes in pressure have a measurable effect only in systems in which gases are involved. And then only when the chemical reaction produces a change in the total number of gas molecules in the system. So take note, changes in pressure will not affect liquids and solids because they are incompressible. And your gases are greatly affected by pressure changes because they are highly compressible. So as we increase the pressure of a gaseous system at equilibrium, either by decreasing the volume of the system or by adding more of one of the components of the equilibrium mixture, we introduce a stress by increasing the partial pressures of one or more of the components. In accordance with Le Chatelier's principle, a shift in the equilibrium that reduces the total number of molecules per unit of volume will be favored because this relieves the stress. The reverse reaction would be favored by a decrease in pressure. Sige. Take note guys ha. Inversely proportional ang aton nga pressure kag volume, no? If pressure is increased, volume is decreased, and vice versa. Alright, so sometimes you will encounter problems wherein instead of using pressure, volume ang ginagamit na term. Alright, so you have to remember volume and pressure are inversely proportional. So if you increase pressure, you decrease the volume. If you decrease pressure, you increase the volume. Let's have an example. So guys, with equilibrium mixtures involving your gases, ang ilang tawon naton is only your gaseous species. And ang i-consider naton is ang number of moles of the gas. So take note, a change in pressure can affect only a volume, the volume of a gas, but not that of a solid and liquids because they are incompressible. So the question here, predict the direction of the net reaction in each case as a result of increasing the pressure, thereby decreasing the volume on the system. Okay. So hambal pagina, we look at the number of moles of the gas. So according to Le Chatelier's principle, the system will adjust to partially offset this stress, which is increasing the pressure. So in other words, the system will adjust to decrease the pressure. So this can be achieved by shifting to the side of the equation that has fewer moles of the gas. Sige. Letter A. Do not mind your solid species here. All eyes on your gas species. Again ha, increasing the pressure is the stress. So for the system to reach equilibrium, it needs to shift to the side wherein there is fewer moles of the gas. So between 3 moles of oxygen and 2 moles of sulfur dioxide, sa diin nga side ma-shift ang equilibrium.
Sa sulfur dioxide, ma'am.
So what side is that?
Sa right, ma'am. Left to
Okay,
right.
very good. Yes. Next, letter B. Lantawanin nyo da. We have 1 mole of PCl5, 1 mole of PCl3, and 1 mole of chlorine. So sa inyong product side, we have 2 moles of the product versus 1 mole of the reactant. Sa diin ay nga side ma-shift.
Sa left side, ma'am.
Okay, very good. Kaya again ha, in increasing the pressure, we need to decrease the pressure. And that is achieved when we shift to the side wherein there is fewer moles of the gas. Right? Next, what about letter C? Ano ay matabo sa letter C? As you can see, we have 2 moles of the reactants and 2 moles of the products. What does this tell us? The question is the system at equilibrium, yes or no? Very good. Yes, the system is at equilibrium. 2 moles of reactants, 2 moles of the product. So therefore, increasing the pressure will have no effect on a system at equilibrium. Alright? I hope intindihan na kita ha. So with pressure changes, ang i-consider naton are the gases. And if we increase the pressure, we need to shift to the side wherein there is fewer moles of the gas. Okay? Next, changes in temperature. So temperature has a profound effect on most reactions. In the first place, reaction rates usually increase with an increase in temperature, meaning that equilibrium is reached sooner. A change in concentration, pressure, or volume may alter the equilibrium position. That is, the relative amounts of reactants and products, but it does not change the value of the equilibrium constant. So only a change in temperature can alter the equilibrium constant. So whether you should raise or lower the temperature of a reaction mixture to increase the equilibrium amount of product can be shown by Le Chatelier's principle. So we need to consider whether the reaction is endothermic or exothermic. So I do not know if you have encountered these terms before. Okay, but to simplify, endothermic reaction is a heat absorbing reaction, whereas exothermic reaction is a heat releasing reaction. So for an endothermic reaction, the amounts of products are increased at equilibrium by an increase in temperature. So that is written, yes, that is written here. Next, for an exothermic reaction, the amounts of products are increased at equilibrium by a decrease in temperature. So basically, a temperature increase favors an endothermic reaction, while temperature decrease favors an exothermic reaction. So according to Le Chatelier's, as the temperature is raised, the reaction shifts to form more reactants, thereby absorbing heat and attempting to counter the increase in temperature. Okay, what do you need to know in temperature changes? You need to identify first whether the reaction is endothermic or exothermic. And from there, mabalaan ninyo kung sa diin nga side ma-shift ang reaction. Let's have an example for an exothermic reaction. So looking at the equation there, paano mo mapalaan na exothermic reaction siya? You will know if you see heat is on the product side. Kaiman, ano gani hambak ko kagina? Exothermic reaction is a heat releasing reaction. So, it releases heat as a product. We have two scenarios here. What happens when we increase the temperature in an exothermic reaction? So ginaano ko gina-emphasize ko gidya nga ang amuni is nga amuni nga reaction is exothermic, ang amuni nga reaction is endothermic. Because identifying kung endothermic siya or exothermic siya, mabalaan natin if which side of the equation ma-shift ang aton na equilibrium mixture. Okay, so when temperature is increased, take note, reaction will shift to the left to relieve the stress, thereby increasing reactant concentration and decreasing product concentration. Scenario 2, what happens when temperature is lowered? So it's the opposite. Reaction shifts to the right, therefore increasing product concentration. So, malain ini siya kung endothermic ang reaction. So, an endothermic reaction is a heat-absorbing reaction. So, heat is here in the reactant side. Alright? Scenario 1 for an endothermic reaction. When temperature is increased, so reaction will shift to the right to relieve the stress, thereby increasing product concentration. Scenario 2, when temperature is lowered, reaction shifts to the left, therefore increasing the reactants and decreasing the concentration of the product. Okay? So, dumdumon nyo ini. Temperature increase favors endothermic. Temperature decrease favors exothermic. Endothermic reaction, amounts of products are increased by an increase in temperature. For exothermic, amounts of products are increased by a decrease in temperature. Alright? Let's have another example. Oh, so, kamu ma-decide. Carbon monoxide is formed when carbon dioxide reacts with solid carbon. Is a high or low temperature more favorable to the formation of carbon monoxide? Oh, so paano mo mabalaan? If the reaction is exothermic or endothermic, kay man, wala ka may makita nga heat. Is it in the reactant or product side? So you look at this, the delta H value. Take note, a positive delta H value tells us that the reaction is an endothermic reaction. While a negative delta H value tells us that the reaction is an exothermic reaction. Guys, ang dasig naman lang ta, itapuson ko lang, kag idasigon ko na lang ha, kay by 12, mapasipiyo ako. May meeting kami. Sige. So, ang question diri, gusto naton formation of carbon monoxide. Diba? Endothermic ang aton nga reaction. Ano galing to hambal kagina? Endothermic reaction favors an increase in temperature. So, an increase in temperature means increase in the products. So, therefore, children, yon. If we want to increase concentration sa aton nga carbon monoxide, which is our product, so we need to increase the temperature. Okay? Kasabad. Wait lang, Akiyo. Okay. Last factor, we have effect of the catalyst. Take note, it does not affect equilibrium. Okay? Just like it does not it remains unchanged sa aton nga reaction rate. So it only increases, it merely speeds up, the attainment of equilibrium. Diba? Your catalysts are unchanged and unaffected sa aton nga chemical reactions. Okay. Guys, may klase ka mo after this? Guys?
Yes, ma'am.
May klase ka mo? 12?
Wala, ma'am.
O sige, 5 minutes. 2 more slides. Tapuson talanggit. Hindi, 3 more slides. So, half-life, children, half-life, represented by this abbreviation, T subscript 1/2. So, is the time required for 1/2 of a given amount of reactant to be consumed. Let's have an example. The composition sang aton nga hydrogen peroxide. So in the first half-life, that is from 0 hours to 6 hours. So it's the first 6 hours. Concentration of H2O2 decreases from 1.000 molar to 0.500 molar. Next, in the second half-life, that is from 6 hours to 12 hours. So, natunga ang inyo nga 0.5 molar to 0.25 molar. In the third half-life, natunga man ang inyo nga 0.25 to 0.125 molar. So, basically, it's half-life, natunga ang inyo nga concentration sang inyo nga reactant. So for a simple representation, so amuni siya, no? So this is the initial amount, which is 100%. So as you can see, nagatunga ang iya nga concentration. So important ini siya, especially sa excretion sang mga bulong sa aton nga lawas. Kay man, if ang bulong sa lawas naton, hindi siya mag-lessen ang iya nga concentration, so may possibility of poisoning or toxicity. Alright? Next, enzyme catalysis. Okay, so ang enzyme natin, guys, they are referred to as biological catalysts. So as catalysts, they speed up chemical reactions in the body. Okay, so here we have Emil Fisher. So he was the one who proposed a model for enzyme catalysis describing the specificity of the enzyme. Okay, so Ari sa picture, it shows just that. As you can see, we have here the substrate. It binds perfectly sa active sites ng aton na enzyme here. So only then na makabind si substrate sa enzyme, it will form an enzyme substrate complex, and then products will form. As you can see, enzyme ninyo is still intact because it remains unchanged or unaffected. However, as years gone by, there are scientists who in a way ano gani wala man nila gin disregard ang theory ni Emil Fisher. It's just that nag-hypothesize man sila na ang enzymes naton can also be flexible. Okay? Meaning sina bisan lain ang shape sang aton nga substrate, your enzyme can change its shape so that it can accommodate the incoming substrate. Okay? Basi hindi nyo magets. Kay man ang specificity model ni Emil Fisher, ginahambal niya, the substrate fits into the enzyme like a key. Diba? Ano gani ang yabi? Diba? Kung sala ang yabi, hindi maabrihan ang kandado. Diba la? So, amula iya ang hypothesis ni Emil Fisher. Dapat, kung sa lock, kag sa key, dapat, ang mumani ang substrate and enzyme naton. Diba, hindi pwede nga, pinalagpat lang nga substrate. E, diba, kung palagpatan ta ang yabi sa kandado, hindi man magbukas. Diba la? But as years go by, may mga research na ginpakita that our enzymes are also flexible. They can accommodate any shape of the substrate. They can change their shape. Alright, that's it. So we will discuss more of enzymes when you reach second year in biochemistry. Okay? So ako man gihapon nagatudlo biochemistry. So I'll see you then. So something to look forward to, di ba na? Sige. So that's it, guys. Masabad. Okay, guys. So madamo gid ka salamat. Pasensya gid sa ginkuha ko nga 7 minutes sa inyo nga oras. So we will see each other next week. Ma-continue kita discussion on acid-base equilibria. Do your research, do your study, prepare sa class. That's it. Bye everyone! Enjoy the weekend. Wala klase buwas. Kay may conference kami. Bye!
Bye, ma'am.
Bye,
Thank you.
ma'am.
Bye.
Thank you, ma'am.
CPU ba? Kasi eh.
Bye everyone!
Ano ni man ang CPU man? Kung ba ang CPU mo?
Bye guys!